So in this topic, we're going to revisit the parabola once again. Okay, so we've looked at the parabola as a locus in tuner math, but we want to go a little bit further than that. Let's say we have a parabola given by x squared equals to 4ay. Okay, we should know everything associated with this parabola. For example, the idea that a is the focal length. And of course, the focal length tells us how far the focus is away from the vertex of the parabola. And we also know that every parabola has a directrix. Okay, so normally we've got a focus at S0, A, and normally we're also going to get a directrix, okay, which is A units underneath the vertex. So in this case, that's going to be y is equals to negative A. Now, what we want to introduce in this topic is the idea of parameters, okay? So the idea of a parameter is that it's a third variable that connects x and y together. Normally speaking, when we're looking at a Cartesian equation, how it works is we take a particular x value, we substitute it into the equation, and that's going to give us a resulting y value, okay? The idea of a parameter is that it's a third variable. For example, the parametric equation of the parabola is given by x equals to 2ap and y is equals to ap squared. A, of course, is the same as the value of a that you guys see in the equation x squared equals to 4ay. It represents the focal length. So in other words, it's a constant. P is a parameter. Okay, so what we do with this third parameter is that if p is equals to 1, that's going to give us a unique x value, and it's also going to give us a unique y value. And I can repeat this for a number of different values of p, right? So if p is equals to 2, well, in this case, when p is equals to 1, I know that x equals to 2a, y is equals to a times 1 squared, which is just a. If p is equals to 2, we can see that x is equals to 2a times 2, which is 4a. And our y value is going to be given by, of course, a times 2 squared, which is 4a. So each value of p gives us a unique x and a unique y, which in turn gives us a coordinate, okay, or a point on the parabola. So if the small p is equals to 1, we're dealing with the point 2a, a. If small p is equals to 2, we're dealing with the point 4a, 4a, etc., etc. Okay, so the idea of the parameter, all we need to know right now is that it's a third variable that tells us what the x value is, and it also tells us what the y value is. Now, you might wonder why we do this, okay? On face value, when we first talk about it, it seems like things are more complex. Why do we actually have 3 variables instead of 2? Well, as it turns out, when we are actually more familiar with parameters, actually expressing everything in terms of p is actually going to make algebra for harder questions a lot easier. And we'll see that as we progress through the course. But for now, we'll just take note that p is essentially a third variable that tells us what x and y are separately. Now, that being said, also take note that the parameter doesn't always have to be represented using the letter p. Sometimes we could use other letters such as q or t. So x equals to 2at, y equals to at squared is exactly the same as what we have over here, or we could have x equals to 2aq, y is equals to aq squared, etc., etc. Now, how do I know that x equals to 2ap and y is equals to ap squared actually represent the parametric equation of a parabola? Well, if I take the equation x equals to 2ap and y is equals to ap squared, okay, if I want to re-express parametric equations as a Cartesian equation, what we'll need to do is we need to eliminate the parameter out of both equations. So I can do this by starting with x equals to 2ap. If I rearrange, I'm going to get p is equals to x over 2a. And of course, if I take this value of p and I substitute it into our second equation, you guys can see that the resulting y is equals to a times x over 2a squared, right? If I expand this, I'm looking at a times x squared over 4a squared. A over 4a squared cancels, giving us x squared over 4a. And of course, if I multiply the 4a to the left, this is now going to give us x squared is equals to 4ay, which is the standard equation of a parabola. Okay, and what this shows is that x equals to 2ap, y is equals to ap squared are indeed the parametric equations of the standard parabola. So what can I do with parametric equations? Let's check out an example, right? Let's say we check out example 1. We want to consider parametric equation x equals to 2t, y is equals to t squared. So in this case, you guys can see that we're not dealing with the parameter p. Okay, we're dealing with the parameter t, but the standard form is exactly the same. So in comparison, we're looking at x equals to 2at, y is equals to at squared. If we want to deal with the parameter t rather than p, okay, it doesn't really matter what letter we choose. And in this particular question, okay, when I look at 2t comma t squared, it's quite obvious that a is equals to 1, isn't it? So a is actually equals to 1 for this particular parabola. And just to eliminate, because part 1, we want to eliminate the parameter to find the Cartesian equation of the curve. So if we check this out, okay, so part 1, where we know that x is equals to 2t and y is equals to t squared, from x equals to 2t, we know that t is equals to x on 2. If I take that and substitute it into y is equals to t squared, we're looking at y is equals to x over 2, that's going to be t, square that, which is equals to x squared over 4. So if y is equals to x squared over 4, it's quite obvious that x squared is just 4 times y, and that also tells us that a is equals to 1, right? Because normally, if x squared equals to 4ay, and we just have x squared equals to 4y in this case, right? It's quite obvious that a is equals to 1. Now, if I want to sketch the graph, okay, part 2 wants us to sketch the graph, and then part 3 we want to look at the vertex and the focus and stuff like that. So if I get a graph out, let's say I've got my x-axis, and let's say I've got my y-axis. Okay, so y, x, origin. Okay, take note this is part 2. I'm just sketching the graph, and the sketch of the parabola should look something like this. Okay, so this is x squared is equals to 4 times y. And since we said that the focal length is equals to 1, right, we know that. So part 3, vertex of the parabola is given by 0, 0. Okay, and focal length is 1 unit, then the focus, okay, s is going to be 0, 1. It's going to be 1 unit away from my vertex. So it's going to be sitting right here. So that's s 0, 1. Okay, so that's all we have for part 3. Now moving on, part 4, okay, what value of t gives the coordinates of the vertex? Now, if we know that the vertex is given by 0, 0, take note that the parametric equation representing this parabola, okay, parametric equations, is given by x equals to 2t and y is equals to t squared. And if we think about this, if we want x to be 0 and we want y to be 0, then it should be quite obvious that the parameter t is going to be 0. So t equals to 0 right now, just this single value of the parameter is representing a single point, okay, on my parabola. So instead of having to deal with points on the parabola as having an x and y value, when we're dealing with parametric equations, a single value of the parameter corresponds to a particular point. Okay, and hopefully from that we can kind of catch a glimpse of how parametrics can actually help us. Okay, single value of the parameter, okay, corresponds to a single point on my parabola. And now lastly, for part 5, right, we want to find the coordinates of the endpoints of the lattice rectum and the corresponding value of t. So if I come back to the diagram, right, the lattice rectum is simply the chord that passes through the focus, which is parallel to the directrix. So in this case, it's simply the horizontal line that passes through the focus. So let's call this point here A, and let's call this point B. If I want to find A and B, all I have to do is come to the parabola, the equation of the parabola x squared equals to 4y, and let y is equals to 1. And that's going to give me the corresponding values of x, which I need. So if I check this out, okay, so part 5, for A and B, I am going to let y is equals to 1. So I'm looking at x squared equals to 4. So x equals to plus or minus 2. So according to my diagram, A is going to be negative 2, 1, and B is going to be positive 2, 1. If I just label this, this is positive 2, 1, and this is negative 2, 1. So I've got the coordinates for the endpoints of the lattice rectum now. So what values of t give these coordinates? Well, if x equals to 2t and y is equals to t squared, if I want x to be -2, that suggests that t is equals to -1. And if t is equals to -1, y is equals to -1 squared, that's going to give us +1. So therefore, for this point A, we know that the corresponding value of t is just -1. So this single parameter defines this point, okay, both the x and the y value. If I look at B, given by 2, 1, right, if I want 2t to be equals to +2, that indicates that t is equals to 1. And if t is equals to 1, y is equals to 1 squared, which is +1. So the second point for B, right, is defined by the parameter small t is equals to 1. Okay, so once again, you guys can see that the 2 points on my parabola are each defined by a single value of the parameter. Okay, so what we have to take into account right now is that parameter is a third variable, and a single value of that parameter is supposed to define an x value and a y value. Okay, and that's all they are. And we can find, if we're given parametric equations, the Cartesian equation by eliminating the parameter from the two parametric equations. Okay, so this is an introduction to parametric equations of the parabola. Okay, and this is what we'll be doing for this whole topic. This concludes example 1.